Okay, so welcome back, and in this short video we're just going to be looking at the reactions of the carboxylic acids. So we're going to be looking at the reactions of the carboxylic acids themselves, looking at reactions with carbonates and the esterification reaction and the reaction with bases. We're also going to be looking at the test for the OH functional group.
Okay, so I've got a range of household ingredients here, and we're just going to demonstrate the reactions of acids with carbonates. So I've got some lemon juice, which is going to contain some citric acid. I've got some Coca-Cola, which contains phosphoric acid, and I've got some vinegar, which contains ethanoic acid. And I've got these little cases, these are just tea lights, where I've taken out the wax. So a little bit of lemon juice in that one, so it's lemon juice, and then a little bit of Coca-Cola in that one, and a little bit of vinegar in the last one. What we're looking for when we add our next ingredient is some fizzing, because what I'm going to add is some bicarbonate of soda. Now bicarbonate of soda is going to contain hydrogen carbonate and carbonate, and hopefully what you'll see as I add them, you might need to get closer.
No, which one are you doing first?
That one.
That one.
Okay, so when I add, you should see it makes nice fizzy on that one, and then I'm going to try it with the Coca-Cola. Okay, you should see that one doesn't fizz quite as much, and then last but not least I'm going to try the lemon juice. Again, fizzing there. This one probably was the ethanoic acid, then the citric, and then the phosphoric acids. But they all fizzed and they all gave off carbon dioxide gas. Okay, so that's the first of the tests for a carboxylic acid functional group. And cut.
Okay, so the first reaction was one of the reactions you saw in the video. And this is one of the first tests, and it's probably the easiest test for an carboxylic acid. You're going to add a small amount of carbonate. Now that could be aqueous carbonate, in this case it was a solid carbonate. And the observations is you get fizzing. You might have noticed it gets warm, but the major thing you get is fizzing. Now if I bubble that through lime water, I will see the lime water turn cloudy. Okay, now from the fizzing I can deduce that a gas is evolved. Please be careful, make sure you know the difference between an observation and a deduction. The observation is what you observe. You observe fizzing, you don't observe a gas. The deduction from that is that a gas has been evolved. The lime water turned cloudy tells me that gas is carbon dioxide. Therefore, I can say an acid is present. Okay, so fizzing is my observation, deduction gas evolved, observation lime water turns cloudy, deduction the gas given off was CO2, carbon dioxide. So in terms of the reaction, I'm going to start with my carboxylic acid, and I'm going to use ethanoic acid in this case, which is a vinegar one. In the video I added some bicarbonate of soda, some sodium hydrogen carbonate. In this example I'm just going to add carbonate. It's exactly the same reaction. You're going to make salt, water and carbon dioxide. So I've got my water, I've got my carbon dioxide, my salts. I've got CH3COO negative, and I need 2 of those, okay, to go with my Ca2+, because it's still got a balance ionically. Okay, the next reaction, and this is one we're going to come back to next week, because this is the esterification reaction. So here I'm adding an acid to an alcohol. I'm adding concentrated sulfuric acid as a catalyst. That's my catalyst. And what I observe is I observe 2 things. I observe when I tip it onto the sodium carbonate, I observe fizzing. That's basically the carbonate neutralizing any leftover ethanoic acid and the sulfuric acid catalyst. And the second observation that I get is it smells fruity. Okay, I've put fruity in brackets because I've smelt a lot of esters over the years, and very, very few of them smell fruity. The vast majority of them smell like nail polish remover. I've also had vomit smell, cheese smell, Gaviscol smell. Occasionally I get fruity, but that is the exception rather than the rule. However, your exam board will accept fruity for any ester. So that's why we say all esters smell fruity. Usually you put that in inverted commas. Okay, so deductions, we've made an ester. Okay, so that's the deductions from that. The reaction, don't worry about it too much because it's something we will be going through when we look at esters in more detail next week. So we have my ethanoic acid. I'm going to add to that my ethanol, and they're going to react together with that acid catalyst, and they make water, and they make an ester. And again, I said I wouldn't worry too much about this one. I will go over that next week. Okay, so the last one here, it's not really a test, so it's not one that you would use to test for carboxylic acid, but it's quite a useful reaction just to know it anyway. So we're going to have some dilute ethanoic acid and we're going to add sodium hydroxide. And what you'll observe is you'll observe the vinegar smell, which is what ethanoic acid smells like, well, because it basically is vinegar, smell disappears. So it did smell like vinegar, and when we've added a little bit of sodium hydroxide, the vinegar smell disappears. The reason for that is you've got the very simple acid-base reaction. So you've got your acid, and you're adding your base, and you make surprise, salt and water. And CH3COO negative, Na positive. Okay, so you've neutralized. So this is enthalpy of neutralization. You've neutralized the acid. That's why the smell disappears. If you evaporate to dryness, you get this left on its own. This is a white solid, as all sodium salts are. If you add some hydrochloric acid to this, because it's a weak acid, if I add a stronger acid like hydrochloric, I will basically get the carboxylic acid reforming, and you'll get the vinegar smell back. Okay, so HCl stronger acid than ethanoic, because it can force the proton back onto the acid here. Okay, so this is the last reaction that we're going to look at in terms of the testing for the carboxylic acids, and this is a very specific test. This tests for the OH group. So this tests for my OH group, so it works with all alcohols and carboxylic acids. So if it has an OH group, this will react. Okay, now it's one you come across before, because you come across it in the alcohols pack, and this is basically adding solid phosphorus pentachloride and keeping it very dry, PCl5. When you do that, you get steamy fumes as your observation. What you can deduce from that is you've got HCl gas coming off, hydrogen chloride gas being produced. Okay, so what happens there is you start with your ethanoic acid, CH3COOH, you react that with the PCl5, I'm going to go over the line here, and you get HCl, that's what you're seeing as the steamy fumes. You also get POCl3, and you get this new compound. And the reason I'm drawing this new compound out is this is the one I'm going to start talking about in the next video. This is an acyl chloride, and this is the next functional group you're going to learn about. Now, we can confirm this by doing two subsequent tests. We can take some of this gas here and we can bubble it through silver nitrate. And if I do that, if I take my HCl and I bubble it through silver nitrate, AgNO3, you're going to get AgCl, solid, and you're going to get HNO3. And it's this that I'm interested in because this is a white precipitate. So that would confirm the observation of the steamy fumes. So it's a secondary test to confirm the first bit. The other way you could confirm is you could react the gas coming off with some concentrated ammonia, and you get ammonium chloride, and that is white smoke. So this ammonium chloride is actually a solid. These two are gases. So these two gases react together to form this solid, and it looks like white smoke. So don't get it confused with this one. So HCl, steamy fumes. Ammonium chloride is white smoke. They do look quite different. Okay, so that was just a short video today looking at the reactions of the carboxylic acids. The next video we're going to move on and look at acyl chlorides, which is the last functional group of this week that we need to study. So until then, take care, stay safe, speak to you soon. Bye bye.